I'm KARIN WOLOK. I have my own consultancy. I do developer relations and developer community type stuff. It's called Project Elevate. You can find me, KARIN WOLOK, on Twitter if you feel the need to tweet, or I don't know if you're one of those people who tweet. So I'm going to be talking about a real-time and historical NLP-enriched market dashboard using Risingwave and Chat-gpt. I am going to include like everything that I'm saying. I also included as speaker notes on the slides. I'm breaking it down so you don't have to read it as I'm saying it, but it will be available for you guys to read as we're going through. In case you miss something, you'll be able to read it. Yeah, and hopefully it's interesting to you guys. Okay, so to get started, this is going to be the talk outline. We're going to first go over the benefits of using streaming data on generative AI, and I'll talk a little bit more about stream processing. For a show of hands, is anybody here like currently using streaming systems like Kafka, Red Panda, or anything like that? Okay, so we have a lot of people who are familiar with streaming systems. Hands for familiar with streaming systems? Okay. So we're going to talk a little bit about stream processing, and then I'll talk to you guys about Risingwave, which is what we're using here. It's a SQL-based streaming processing system. I'll talk about that. And then I'll talk about the use case on how we built a ChatGPT stock indicator thing, which was surprisingly a lot more accurate than we expected. And then that's the demo that we're going to do. Now, because I'm sharing slides here, I won't be able to show you guys the actual demo. But if you guys want resources, I can get that for you too. But there is like screenshot and everything of like the code and what the demo looks like. It's just not going to be live. Okay. So first, the benefit of generative AI on streaming data. So the first thing is that you have the ability to generate synthetic data for training and testing machine learning models. And then you can also identify anomalies in streaming data and forecast future events. I'll talk a little bit more about like streaming analytics in general and stream processing and what that means, so you'll have a little bit of a better idea of how it's applied in the generative AI space. But yeah, so that's that, which I kind of just spoke about. So I don't need to read you guys the definitions, but generative AI being a type of artificial intelligence that creates new data. And streaming analytics is basically the process of analyzing the data as it's coming into your systems. So that's essentially what it is. Streaming events brings the data in real time. Stream processing allows you to run transformations and processing on that data as the streams are coming in, which is like basically as real time as it gets, right? You can't do it before the events happen. I mean, maybe one day we can, but not right now. Okay. Let's see. Okay, so understanding stream processing. So streaming data, since there's some people who are not as familiar with streaming systems, that allows you to bring in the data in real time. As an event happens, you're able to ingest the data. So stream processing basically allows you, like as these live events are happening, so anytime a user takes an action or you have any other kind of new information that's coming in real time, you're able to run transformations and processing on that data and then output it somewhere. So this is the case. I'll talk a little bit more about this too in terms of like what Risingwave does. But stream processing, I have the definitions kind of written out on here as I mentioned before. It's a data processing approach that deals with the continuously flowing data and involves the ability to do real-time analysis, transformation, computation on the data as it arrives into your systems without the need to store it in a traditional database. And you can extract valuable insights, detect anomalies, and trigger actions based on the data being as real-time as you want. Type of queries, we're going to talk about the type of queries in stream processing. I think this is kind of important in terms of like what type of actions processing you can do inside of your streams. So one is filtering. This involves the selection of like specific data from a stream based on predefined conditions from you. So one of the examples is filtering out. I feel like I updated this, but okay. I made these italic at one point, but I don't know if maybe it didn't work. But so you're filtering out log entries that contain errors for immediate attention. That's an example of one. Another type of query is aggregation. This basically involves summarizing or reducing the data over a certain time window or key. And the example of that is calculating the average temperature over like the last 10 minutes from like a sensor stream. So you can create this window. And then joining streams, which I think this one, I don't know why, this one I think is like the cooler one. So this is where you can actually combine data from multiple streams based on a common key or condition. Actually, with this example, we do kind of do that. And with Risingwave, if you ever did decide, you can actually combine dozens of streams, which is really cool and complicated, but it's fun if you have the ability to do it. So the example of that is combining user click data with product data to analyze user behavior. So you're taking two different streams of data, combining it to provide some kind of real-time insights. Okay, another example of queries. We're still talking about the queries in stream processing. And this is windowing. This is basically these queries group data into fixed time intervals or windows for analysis, which we do a little bit of that too with like the demo that we'll talk about. So example is like analyzing the total sales for each hour of the day over the week. Also pattern recognition, identifying specific sequences of patterns or events in an event stream. That's like another type of processing you can do while the streams are coming in. This helps with like kind of like the more popular use cases of like anomaly detection and things like that. Detecting a series of login failures as like a security breach attempt. So you're looking for patterns in data and seeing if there's any anomalies, things like that. And stateful processing, which is you maintain state, maintain state information to analyze data over time. So such as tracking user sessions. So monitoring user behavior and detecting when a user session is idle. So these are some examples of the things you could do with processing your data as it comes in. If you think about real-time analytics too, it kind of falls into that space. But it's essentially being able to run queries on your streams as they come in. So I'll talk a little bit about Risingwave because we will be using it for this example. So Risingwave is an open source distributed SQL database for stream processing. So it's basically designed to reduce the complexity and cost of building real-time applications. So streaming data is very useful for real time. So what it essentially does, it consumes the streaming data and then performs incremental computations when the data is coming in, as I said, like during the stream before it gets put somewhere, and then it updates the results dynamically. I did put, there's the last, well, I'll get to it in a second. It also has a downstream system, so as I mentioned, it's a database. Risingwave is like, it does have the downstream side of the stream processing, which is nice. It maintains its results in its own storage, so you can access that data efficiently if you're running more types of queries. It's SQL-based and Postgres compatible, which is really nice because SQL is very popular and easy to use. So you could essentially, what you're essentially doing is running SQL queries on your streams as your real-time data is coming in. It does have the ability to separate, like the storage and computation remain kind of independent of each other, so you can scale them out separately if you need to, more for like a cost kind of thing. This kind of goes with our earlier bullet point, but it has incremental updates on materialized views, which is also really nice. Okay, so talking a little bit more about Risingwave. So Risingwave accepts data from sources like streaming sources like Kafka, Kinesis, Red Panda. If you guys haven't visited Red Panda, they're over here. And other materialized CDC sources. And then you could do the processing, and then you can output it into your data warehouse, into Risingwave itself as it's a database, or data warehouses, data lakes, or even additional processing. So even if you wanted to feed it back into the stream, you could process the data, feed it back into the stream, process the data, just go in circles. No, I'm just kidding. But you do have the ability to do that, so the downstream thing. But you're basically doing the processing in the middle layers there. Okay. I don't even know what I'm looking at right here. Yes, so that's, so an example of a Risingwave use case is you can actually do ETL, but as the data comes in real time. So basically, which I kind of mentioned before, but this is like the use case of like doing real-time ETL. You ingest the data from a wide range of data sources. You can transform it, which is like where you're doing the processing, all kinds of data transformation. And then you can load it, as I mentioned, the downstream to any kind of downstream system. Doop, doop, doop. Okay. Another example is real-time analytics. This is a very common use case. I think a lot of people are familiar with analytics in like the dashboard sense, real-time analytics or any kind of real-time system. So like one is you could have the analytics that are shown to you in like a dashboard, or you can use this like real-time analytics to create parts of your products that encourage more user engagement. So if you productize what they call actionable insights, like you hear about an event, it comes in real time, and you're able to do some processing on it and then show it to your end user, you can then empower your end user to take action or make a decision or something along those lines based on finding out that real-time insight. So basically anything that you're getting from any kind of application that you're using, you know, your order delivery apps or whatever, and then you get some kind of notification that they're out of something or whatever, you can then make a decision, right? That's what's called like the actionable insights for the users, for your end users. So that's kind of like where the real-time analytics can really be useful. There's a lot of stuff about real-time analytics and actionable insights if you want to read up on that. Yeah, so that's I think I have some bullet points. The practice of analyzing data as it's generated provides business with valuable insights in real time and can provide a competitive advantage. Obviously, every user wants data and information in real time of whatever's happening. You know, if I look on my LinkedIn on who viewed my profile, I want to know who viewed my profile now, not 10 minutes ago. And that's like where you're talking about like your customer or user engagement. And can improve operational efficiency and reduce costs. I mean, there's a lot you could do with real-time data and real-time insights. Another example is event-driven applications. Again, like everything that is real-time. You have events coming in. This, Risingwave on its own with streaming systems like Kafka or Red Panda, as I mentioned before, but enables you to be able to ingest the events as they're coming in. You can maintain context around multiple events and performs like sophisticated processing, detects complex patterns. This is where you can use with like fraud detection and things like that, that all the data really, really needs to be as fresh as possible. And so Risingwave has a direct integration with the upstream and downstream systems, which is very useful. Okay, talking a little bit about the architecture. So first thing is you have a serving layer at the top. This parses SQL queries and performs planning and optimization of query jobs. Then you have a processing layer, which performs the computation. Metadata management service manages the metadata of different nodes and coordinates operations among these nodes. And then you also have a storage layer to store and receive data from object storage like S3. Okay, so implementing the use case. So as I mentioned, I'm like kind of sharing with their computer. I don't have the ability to share like the live example. But basically, if you imagine this to be totally live in real time and not a screenshot, you can move it around and kind of pull. This is the demo that we're showing. It's like stream processing job for real-time market data, taking into account stark market values, and then how NLP can enrich the daily tasks using ChatGPT. Okay, so as I mentioned before, we're using Risingwave for this, and everything is like pretty much SQL based. So if you're familiar with SQL, you should be able to understand a lot of this code. I probably don't even need to explain it at this point. I could just like click through it, but I'm just kidding. I'm going to explain it. I'll explain it because that's what I'm here for, and then I could just leave. That's how you automate my job, is just find people who know what they're doing. Okay, so first in this case, we're ingesting data with Kafka. So we're connecting Kafka to Risingwave. And with this code, we actually created a table accepting market feeds. And the way we did this is created a Kafka sync downstream into Risingwave. Okay, then we created a materialized view that windows the market feed data. And we created a materialized view from the market feed Kafka topic, which I think was in the last one. And then the view is based on a window function, which I kind of mentioned before, that calculates the average mid-price for a 5-minute window. And then the query groups the data by symbol, stock symbol, and window start time and averages the volume, low, and high prices for each group. Is that helpful to have like what I just said on the screen? Okay. Because you're like, I have no idea what she said. She speaks so fast with an American accent. I don't know how many people here are British, but okay. So in this one, we performed the streaming market statistics in 2 steps. One, we created a materialized view storing the price movement between the 1-hour shifted window and the volume. So we calculated the absolute difference between the mid-price of the current window and the mid-price of the previous window, and then grouped the data by symbol and calculated the move for each group. Okay, so then we performed the stat aggregations for over 24-hour windows. So we basically calculated the standard deviation of the move and the volume columns and the window end time. And then I'm going to make sure I'm like pulling them up as I'm speaking. And then we grouped the data by symbol and window end time, and then selected the columns included in each output. And then the result is a materialized view that contains the market statistic for each symbol and window end time that can be used for analysis and prediction. And then here we performed the streaming outlier detection in 2 steps. One, we created 2 materialized views that filter symbols based on whether the price movement of trading volume has changed significantly over the last 5 minutes. I don't know what that other thing is. Sorry about that. And then 2, fully joined the previous views to get the symbols that either have outlier and price movement, trade volume, or both. Then we defined a user-defined function, a UDF, that takes a stock symbol and an article and some enriched data, it returns some enriched data centered around a stock price, indicator score, and a 1-sentence justification. And then we created and added the UDF using Risingwave's Python SDK. The function sends the prompt to OpenAI's API's chat completion model, and then it receives a JSON response that includes a score, confidence, relevance, relevant similarity, justification, explicit mention, and keywords. We joined the article. I'm going to actually, this text doesn't have any code on it, so I'm just going to share this as I'm speaking about it. So we joined the article metadata stream from a window 1 hour before and 1 hour after each symbol window by creating an enrichment table around the market symbols. And we did so with the following steps. So one, we created an enrichment table around our market symbols, create a source for our newsfeed, and joined our volatile symbols, our keyword enrichment table, and our newsfeed from 12 hours and 12 hours before and 12 hours after to account for market close. So since calling the UDF is costly, we implemented a deduplication. Responses from previous API can be retrieved from the Risingwave cluster. And this way we reduced the number of times we call the API, reducing the overall latency of calling the UDFs. I know this code is small. It's probably like difficult to see from the back. And then finally, we created the real-time streaming output containing both the enriched data, updated in real time, and then the historical closed windows. And then that's the result. This is actually from like the actual demo that they built out. And it was like, as I mentioned, it is like not surprisingly accurate because you would expect it to be kind of accurate, but like, you know, we followed it and tracked it and it actually kind of worked, which is pretty cool. It's a good way to hack the system and make some money. I'm just kidding. So, okay, so with this demo, we achieved the following: big data analytics, complex streaming stats, aggregations over potentially 100,000 plus stock symbols. And we also reduced the cost of recomputation of intermediate and final outputs as new streaming data arrives, and expensive external API calls to Chat-gpt via filtering and caching. And that's it. And then thanks to the guy, Jonathan Trang, who built this demo, and then Federico, who helped with the slides, and then my hype man, Mark, who is not here. He's here at the conference, but he was the one who came over, and I was like, I need you, I need internet. That's Mark Needham, and he's also my best friend. So yeah, that concludes the talk. Thank you guys so much.